Welcome to Unit 3, Day 1, Solving and Graphing Inequalities. Today, we're going to talk about inequalities and interval notation. And the EQ question for today is, how does interval notation compare to the standard notation for writing an inequality? Well, we first need to know what an inequality is. Inequality is a relationship between two values that are different from each other. So we have to remember a couple of things when we start working with inequalities. When you multiply or divide by negative, you must flip the inequality symbol.
Remember that that's not when there's a negative involved in the problem. It's when what you're doing to solve for the variable involves multiplying or dividing by a negative, which is going to change the sign of the result.
Then when graphing on a number line, if less than or greater than, use an open circle. And then if greater than or less than and equal, use a closed circle.
So the way I like to think of this is I like to think of your inequality symbol as a hose and your circle is your pool. And that line underneath is your water supply. If you have just a hose and a pool but no water supply because the water hasn't been turned on by the city yet, you cannot fill your pool, which is why we use an open circle. But if you have that water supply, which is that or equal to, that's when you can turn on the water and you can fill your pool and go swimming to your heart's content. Now that we've talked about some of those important things, let's take a look at how we graph them. So the one thing is we want to have our variable on the left. Because if we have a variable on the left, that's going to help us with graphing. So I see that it says 2. Notice I didn't put any numbers on the number line. What I like to do when I put my numbers on the number line is I like to put the number that I'm working with on the center spot, or as close to the center as possible. So remember, to the left gets smaller, so we go 1, 0. To the right gets bigger, so we do 3, 4. Then we look here and we see that x is at 2, so we put our dot at 2, and it's greater than or equal to, so it's going to be a filled in dot. And then we're going to be dealing with which way do we shade. Well, the beautiful part is this points to the right, so I'm going to shade to the right. I do not want to see you shading above the line. Please shade on the line. Please put your dots on the line. Highlighters work wonderfully. If you'd like to borrow a highlighter, I'm more than happy to share with you. So the other piece I want to mention, like I said, if you have the variable on the right, that's when it's going to actually be the opposite. I like to look at this as being an arrowhead where it points the direction you need to shade. So thinking in that term, looking at the next one, we've got x is less than negative 5. So I'm going to put my negative 5 here. Remember, it gets smaller to the left, which means it gets more negative, not less negative. And we go less negative to the right. And then it's at 5. So I put my circle there. It is strictly less than, so I leave the circle open. And then I'm going to go ahead and shade this time to the left because it's less than. If you're ever questioning if you shaded to the right direction, check your point. For example, in A, if I put in a 3, is 3 greater than or equal to 2? Absolutely. Is negative 6 less than negative 5? Absolutely. You should be checking your work. So now, we look at these problems. These ones take it to the next level because now we need to solve. The nice part is it's not any different than solving an equation. So we can go ahead and we say to get x by itself, we're going to divide both sides by negative 5, which leaves me with x on the left and negative 3 on the right. Notice I divided by a negative, which changed the number on the right from a positive to a negative, so I need to flip the sign. Then when I go ahead to graph, I'm going to put my negative 3 in the middle, so I have negative 4, negative 5, negative 2, negative 1. It is at negative 3. It is a closed circle because of the line underneath. And then it points to the left, so I'm going to shade to the left. Our next one, here we have 4x minus 7 greater than or equal to 13. So now I'm going to start by adding 7 to both sides, which gives me 4x is greater than or equal to 20. And then I'm going to divide by 4, and that gives me x greater than or equal to 5. I don't have to flip the sign because everything stayed positive. So I put my 5 in the middle, 6, 7, 4, 3. I have greater than or equal to, which means I'm going to have a closed circle at 5, and it points to the right with the variable on the left, so that means I'm going to shade over here. The next piece we need to talk about is interval notation.
So when we talk about interval notation, we're using the brackets for closed dots, and we're using parentheses for the open dots.
One of the things that people always ask is, why are we learning the interval notation? Part of it is because we are an IB school, and while I know not a lot of you will take the IB exams when you get to be a senior, it is important to know this notation because you will see it again.
So when we look at the first equation, we've got 0 is less than or equal to x, and then x is less than 4. This is what it means. So we're going to have a closed dot at 0, and then we're going to have an open dot at 4.
And it also means that if we were to shade, notice x is in the middle. So that means we would shade in the middle with having our closed dot here at 0 and our open dot at 4. So when we write this,
we're going to have a bracket 0, comma 4, and then a parentheses, because remember, when we have an closed dot, we need the bracket, and when we have an open dot, we need the actual parenthesis marker.
And we're talking interval. So our interval goes from 0 to 4. That's why we write it this way. It is not an ordered pair, although if we have 2 open brackets, it might look as such. So let's try some. Here we have 6 is less than, negative 6 is less than x, which is less than 4. So when we talk intervals, I'm going to have negative 6, negative 4, negative 2, 0, 2, 4. And I see that I have both less than, so that means I have open dots at negative 6 and positive 4. X is in the middle, so when we shade, we're going to shade in the middle. And when we write our interval notation, I'm saying that x is between negative 6 and 4. Both of them are open dots, so we will use parentheses. So it does look like an ordered pair, but it's not. This is how we write our interval notation. Our next one. First we got a graph. So we go between 2 and 5. So I'm going to do 2, 3, 4, 5, 6. I see that it says x is greater, basically it says x is greater than or equal to 2. So at 2 we're going to have a closed dot. And x is less than 5, so at 5 we're going to have an open dot. When we shade, we're going to shade in between again because x is listed in between the 2 of them. And when we write our interval notation, we're going from 2 to 5. 2 is a closed dot circle, so we're going to use a square bracket. 5 is open, so we use a round bracket.
So now what about x is greater than negative 1? So when we look at this, we need to make sure that we remember that either it's an open circle or a closed. And with it being greater than, then it was going to be an open.
So we're at negative 1, open circle. X is on the left. So which way are we going to shade?
We're going to shade away from negative 1.
Shade to the right. Now when we talk about interval notation, we are starting at negative 1 and we're going to the right forever. And so what happens is this goes to infinity. It keeps going. So when we write this, we go from negative 1 with an open bracket to infinity. Now, infinity we can't include as a solution, which is why we always use an open bracket with infinity. Now, if we look at the other one, x less than or equal to 2. Here, we are going to be sitting with a closed circle at 2 because it's less than or equal to, while x is on the left. And when we shade, we want to go the way it points. X is less than, so we go to the left side. And when we write our interval notation for this, it's going to be, this time we're going this way. This way is to negative infinity. It's not just infinity because it's getting smaller to the negative side. And then we go all the way to 2 with a square bracket. We want to always go from smaller to bigger. So we go to try this now. We got x greater than or equal to 2. So we put our 2 here. We've got a closed circle at 2. And we're going to shade to the right because it's greater. And so when we write our interval notation, we're starting at 2. We include 2 because it's a closed circle. And we're going forever to the right, so it's to infinity with an open bracket. Now, h greater than 0. So we put our 0 in the middle. That means we go -1, -2, 1, 2. And we have an open circle at 0. We're going to shade again to the right because it says greater. And when we write our interval notation, we're going from 0, but it's an open bracket, to infinity. So we use the open bracket there. One last thing we got to talk about, word problems. So we want to always look for keywords here. So when I look for keywords, I'm seeing at least $2,000 and $500 a month plus a commission of 15% of the value of the jewelry she sells. So when I look at this and think in terms of how this works, so we start with $500 plus 15%, we need to write 15% as a decimal, which would be 0.15, of means multiply, so our x, where x is going to be the value of the jewelry. And this has to be at least $2,000. So if you think about it, at least. Is it okay if she earns $2,000? Yes, that means we have the equal sign. At least means it has to be that or more, so it's going to be greater than or equal to. So now we've written our inequality, so then the next step would be to solve it. Due to time, I'm going to have you solve it, and you're going to bring that with you to class tomorrow, and you guys can talk about it there. So what I have for you now, in addition to that, no word problems, just a few of them here we're going to solve. Yep, variables on both sides. You guys can handle that. Graph them both. And then you need to graph the inequality I give you and write the solution in interval notation. And as always, bring your questions with you to class tomorrow.